Here we got a question from JEE Mains 2022 and the topic is gravitation. So let us see what this question is. A body of mass small m is projected with a velocity lambda time ve in vertical upward direction from the surface of the earth into the space. And it is given that ve is escape velocity and lambda is less than 1. So let us see what they are saying. So this is my earth. Let us say its radius is given as r. Okay, so here we have an object of mass m and we are going to project it vertically upward. Let us say v projected, the velocity is v projected. Okay, so what we are given is that v projected or projectile is equal to, sorry, we'll take it this as projectile. Okay, is lambda time v escape. Now we know that escape velocity from the surface of the earth is 2g, mass of the earth and the radius of the earth. Okay, so from here we can say that our projectile velocity is lambda time under root 2g m by r. This is v projectile and this is the initial velocity of mass small m. Okay, so let us see after okay, there's one more thing that is given in this question, and that is that lambda is less than 1. What does this mean? That the v projectile is less than v escape. This means that the small mass m, it will not go out of the environment of our earth, it will not escape the surface of the earth. Okay, that's it. So next part is, if the air resistance is considered to be negligible, then the maximum height from the center of the earth to which the body can go. So they want that what is the maximum height up to which a body can go. So let us say that body reaches this height and this is h from the center of the earth, because in the question it is asked maximum height from the center of the earth. Okay, and if it is a maximum height, then what will be the velocity at this point? V, which will be equal to 0, because at maximum height the velocity will be 0. So we are going to use a law of conservation of energy. So again, applying law of conservation of energy. So let us see the points. Let us say this is our first point and this is our second point. This is the point of the maximum height up to which the small mass m can reach. Okay, so applying this conservation of energy at 1 and 2. Okay, so let us see the energy, the total energy at first point will be the potential energy at first point and the kinetic energy at first point. So the potential energy at first point, again I'll draw the diagram here. This is my first point at a distance r, this is my second point at a distance h from the center of the earth. So this is first point, this is second point. So kinetic energy at this point will be potential energy will be minus g, mass of earth, mass of object divided by the distance, that is r, and the kinetic energy initially it is projected with the velocity v projectile, so half m v projectile square. Okay, so let us put the value of v projectile here, and it will be minus gmm by r plus half m into v projectile is lambda time this term. So if we square it, we'll square it here, v projectile square is lambda square into 2gm by r. Okay, so let's put this value here, lambda square 2gm by r 2, so minus gm m by r plus this is gm m lambda square by r. Okay, this is our total energy at first point. Okay, so similarly the total energy at second point will be the potential energy at second point and the kinetic energy at second point. But as we know that at the second point, that is a point of maximum height, our velocity v will be 0, so this kinetic energy will be 0. And at second point total energy will be the total potential energy only, and the distance of second point from the center of the earth is h. Okay, so from the law of conservation of energy we can say energy can neither be created nor be destroyed. So E1 is equal to E2. E1 is this, so minus G m by R and plus Gmm lambda square by R, and my E2 is minus Gmm by H. So this Gmm is gone, and we'll just shift a little bit. So 1 by H is equal to 1 by R minus lambda square by R, and if we solve it, then 1 by H is equal to 1 minus lambda square by R, and from here the H is R upon 1 minus lambda square. So this is the maximum height up to which our object of mass small m can go. From the options, this will be right. Thank you so much.